Rick, would you like to go first?
Oh, I think according to schedule, I'm the second one, right?
Oh, is
Otherwise, you want me to first? I'm okay.
Yeah, sure. Hongbin, if you are ready, you can go first either.
Yes, yeah.
Sorry, we can't hear you.
I'm open my PowerPoint now.
We can't hear you.
Oh, can I
Hongbin?
Yes.
We can't hear you. Can you like speak loudly or come closer to the mic?
Okay.
Would you like some more time to fix the issue? Okay, maybe you can go second, Cedric, because we are on it. Okay, yep. Hong is here.
Okay, hello everyone. My name is Hongbin, master student. Today is my presentation. My research topic is globalized person name classifiers using the natural language processing. So let's go started. I will go through those methods for my. As part of the artificial intelligences, the natural language processing techniques have been developed significantly. But the question is, why can text classifiers help people to solve the tedious test and analysis classification work? As we can see, is that in this picture 3, the NLP they are used in various industries. For instance, the test classification span jeopardize financial analysis. Among of these aspects, we can see NLP can automatically divide the textual information categories, analyze the new topics, intelligent robots to answer the customer's questions, and the prediction evaluation test involving the business and legal affairs. So that gives me a lot of inspiration. And we all use in NLP technologies everywhere. My motivation is nowadays due to the development of the international trade and the global economics, world economic. Many companies need to develop highly accurate NLP products to meet the people's the demands in work and the daily life. Currently, you can see in the North American technology market. In the markets, we have learned, we have investigated that the four IT giants, they are developing their own NLP products. We can see that amongst these four, the comparison between them can be seen. The four can be found the figure 4. They have Amazon, Google, Microsoft, IBM. Those products can have abilities to do the entities extraction, key phrase extractions, topics, multiple languages support, and more and more. But the reason, but the problem is that some are supported and some are not. So the development of NLP products is very hot and popular in our societies. My research is to implement and optimize the global person name classification test to build how to build and internationalize name and recognition in the product. So this is the biggest motivation for me. when I look at the test classification for the NLPs, there are the serial steps to process. I think this is very important for my research. There are first is the training set. The second is feature engineering. Last is a classifier. As we can see, every step has its role. For my top project, the NRNN, the recurrent neural networks, is a famous supervised deep learning methodologies. RNNs as my methods for test classification. I found the next. Let's see. Yeah, I found that. Yeah. I found out the test classification can train the recurrent neural networks for sentiment analysis. For example, we have heard that the TensorFlow is developed by the Google as used as the test processing tool, or we can choose the PyTorch is also deep learning framework. With the guidance of my professors and classmates, students, I also reviewed a lot of information and literature. Amongst them, I found out three main categories. They are very critical for the project. Most of them mentioned NLP. We can see the recurrent neural networks do not specifically address the aspects of NLP. Since the PyTorch as the frameworks can be used for NLP, there are many related resources, use case, and the code examples. So my approach is NLP was mentioned. We must optimize our Analyst, TM, and GRUs in the models. PyTorch and the RNN can work well together. When I go in the approach sections, I realized that I need to work around these three topics. The data we use is multi-language name data. This includes a total 18 different languages name files, all in the text format. We can see first my purpose is NLP and RNN, the three models, and last is imported PyTorch. Yes, and next I'm going to continue to say that it's the first step I had to say pre-processing the data set. Second is build the RNN models, build the special RNN models along, which is long short-term memory models, LSTM, and it shows the gradient managing problem. Another variation of traditional RNN is the gated recurrent unit structures to reduce the gradient managing. The third step is training functions to compute and train their works and analyze the comparison. Last step is the evaluation function, to evaluate the work and achieve the prediction performance. For the data collection, I collect these and record them. I found out that these are the results of my experiments. First is data preprocessing the tensor. We had this on the testing the model's performance. Third is training and loss comparisons. Last is accuracy of evaluation and prediction. This is the last step, it's the resource. Yeah. When I finish the data collection for my analysis, I analyze the experimental results into two parts. One part, the first part is the loss of RNN is gradually reduced. You can see this loss comparison curve. we had this. The first is a fast and slow represent the degrees of model convergencies. And the best convergency for my project is the traditional RNN. The short orders are, I think, the first position I had to choose the RNN. Second, I will go GRUs. And the last is consider the LSTM. For the training time consumption complexity comparison. So we can see as we can, the time taken represents the computational complexities. The small complex is the traditional RNN, and the second is the GRU, and the third is LSTM. Yes. My findings are based on my problem statement. Also, we consider the wide test classifier help people to solve the tedious test analysis and the classification work. We had to solve the vanishing gradient problem in the process of dealing with the algorithms and the models. Although the RNN is able to do, it's good at remember the short-term information. Under these disadvantages, it's not good at the deal with the long-term information processing. I think yes.
You have 5 more minutes left. This is just a heads up.
Yeah, I think the situation we need to use is how to combine the those three models depending on the specific test. Decide which ones to go to use. So yeah. So conclusion, I have finished those and build 3 models. I violate the 3 algorithm implement and prediction compares the performance of 3. This is an important thing. So it's not the optimal choice if the model shows the higher training abilities and the less time consumption. I think the best solution is obtained by analyzing the experimental results according to the purpose of the study. The future was I will continue to improve these 3 algorithms that are improved continue to through the RNNs, the vanishing gradient problems, and try to find out their advantages and disadvantages. Yes, those are my key reference from those figures I had provided. Yes, my presentation is finished. Feel free to ask me some questions. Yeah, thank you, everyone. Yes.
Hello, Hongbin. Thanks for sharing. But I have a kind of a question. Could you go back to the thinking like data analysis, the 3 line of the model lost? Can I go back to there?
Which page?
Not that one. So I think maybe data analysis.
Data analysis.
Yeah, you showed the result. Yeah. Go back.
Also.
I mean the graph of the 3 models lost.
Is it?
I think. Yeah, this one. Data collection. Yeah, that one. So I found that your loss will. I think it's not the graph is a little. But my kind of suggestion, maybe you can use the gradient clips to limit the gradient. So in that case, well, you can see in your image each time the loss will change a lot. The loss is changed in a very huge level. So I think the problem is that maybe in the NLP, it will usually has something like gradient explosion. I think that's the issue. Maybe you can use the gradient clip. It could reduce this kind of issue. Just a kind of suggestion.
Okay. Yes. Well, I can, because those are just so these two screenshots just for the ones time for my this was the one time obtained it for my experimental result. I had to I should use I should put a lot of put some or three or four the screenshot for here again. Yes.
So, well, that's all. Thank you.
Anybody have any more questions for Hongbin?
Bye.
Okay. Thank you, Hongbin.
Thank you, Mahati. Yeah. Thank you.
so-
Everyone.
Cedric, if you are ready, would you like to start your presentation?
Okay, let me share my presentation now.
Sure.
Can you see my slides?
Yes.
Okay. Okay. Hi everyone. Good afternoon. So this is Guangwei Huang. So today I will introduce my capstone project. My capstone project is deployment of the pre-training deep learning models in cloud platform for online inference servers. And let's go. So this agenda is the item that we will discuss today. So which mainly includes the problem statement and evaluations of this project. At the same time, I will also describe my approach, and there will be a demonstration at the end. Before we start, let's talk about what an inference server is. So specifically, a neural network that has been training can apply what it has learned to task in the digital world. This is faster and more efficient neural network can be making prediction on the neural data obtained based on its training results. In the field of the artificial intelligence, this process is called inference. So then the next question is, the machine learning models for online inference are deployed with hard constraints on a system latency such that the model must return the result within a few hundred milliseconds with the less fault tolerance. How can we solve the performance optimization problem of long online inference servers? Then, so the motivation of this project is when you have a model that has been trained, the next step is to connect the code with the business layer. At this time, the API is as a solution. So the API simplified the way developers integrate new application component into existing infrastructure, which in turn facilitate collaborations between the business and the IT teams. Take the example of the RESTful APIs, which can speed up the delivery of the new feature and updates, or rather, such APIs facilitate this speed increase. So each service in the architecture is discrete. A server can be replaced or enhanced or dropped without affecting any other service in the architecture. This lightweight architecture helps optimize, distribute, or the cloud the resource and support the dynamic scaling of the individual servers. So my final delivered is I just want to deliver the project just like another cloud service. The customer can get started with the machine learning quickly without having to install the software or configure their own servers. Then the background from this figure, we can see some engineering concepts involved in this project. business blocks have different sides, so it can be clearly seen that in the real world, only a small part of the machine learning system consists of the machine learning code. As shown by this small black box in the middle, the required surrounding infrastructure is large and complex. So talking about the related technology, so I will use the Python as the core programming language for the backend web. And I will also use the end-to-end open source machine learning platform, the TensorFlow, which help to provide a lot of built-in library or function. And the Flex is a lightweight multiple page web framework. So also there is the other deploying technology called TF serving. And I will use Docker and AWS to deploy the containerized projects to the cloud platform. So so for the first related work, so the other research have concluded this figure describing the prediction pipeline between the consumer, modular, and the module mute combination. For the prediction stage, the model is ready to predict. The consumer send the predict set to the modular composite predictor component, which will forward to the model instance predictor component. Also, where the prediction is calculated and returned to the modular. The prediction are sent to the prediction storage to the stored and served. So that's basically process for the online service, online inference service prediction. And this figure shows the impact of the containerization on the high performance computing. So with Docker, you can use a container as a lightweight modular virtual machine. At the same time, you gain the flexibility to efficiently create, deploy, and replicate container and migrate them smoothly from one environment to another, helping you to optimize your application for the cloud platform. So regarding the choice of the technology stack for the deployment model, there was a research team on the high performance calculation point out the container are more lightweight set of the isolated environment without additional virtual hardware. It is especially suitable for the AI application. The Docker has relatively unique layering mechanism. A Docker image contains multiple layers, and any internal modification are only saved in the current image layer. The change in the container are only saved in the container layer will not affect the image. So that's the reason I'm decided to use the Docker to as a part of my solution to deploy my project. Then this figure shows there is a 4 model compression method. So many real world tests usually relied on the deep neural network with a million or even billion of parameters. Such a complex large scale model usually have extremely high requirement on the compute CPU or GPU and GPU, and consume a lot of memory, resulting in a huge computational cost. So at present, the method commonly used in the model compression and acceleration can be roughly divided into 4 categories. So the first one is purine and the quantization. That's a parameter purine, and the second one is a low rank factorization. And we also have the transfer compressed convolutional filter. We are the last one, the KD, is knowledge distillation. 2 of the compressions technology I use in my project are purine and quantization. Okay. So in this part, I compared the technical path, the difference between the different related research team. mainly from the three compression technology, deployment technology, and the performance evaluation to observe the similarity or the difference between them. So it's hard to say which method is the best, but in the last column of the matrix, I showed my current approach to all three. So okay, let's go to my approach. So in the practice of pre-training model is important. It's important to predict the target variable. Then the means, the square arrow is checked, and the unpairing model becomes the baseline model. So after this, we will compare it to the whole pure model, focus on mainly on the model size and the compressed model accuracy. So the second compression method is to perform the post-training quantization on the project. The model of the project is composed of the weight and the bias, which the weight and the bias are stored in the using the flow32 data type, and the flow32 occupies. Sorry.
You have 5 more minutes left.
Okay, thank you. So so the model quantization is a process of the replacing the flow32 with a data type with fewer digits such as integer 8 to represent the weight and the bias of the model to reduce the size of the model. So the goals are such as reducing the model memories, consuming, and speeding up the model inference. So right here is the in the project, the pre-training model structure is a customer autoencoder. So the autoencoder is a type of artificial neural network used to learn efficient coding of the unlabeled data. So its main task is to extract effective picture from the grayscale image and colorize the grayscale image. So for the data collection, by using the model optimization tool provided by TensorFlow, the research practice reduced the size of the model to only 25% of the original size, while maintains a comparable level of the accuracy. So for this data analysis, I'll quickly explain that. That's the image processing timing from the back end. Also, the flags initially start in the local and Docker. So we compare the two different states. That's before the containerized and after that. So that's the two different timing using in the before the technology apply. And for data analyze, so from this figure, using the HTTP cache to define the packaging, trying to package scripts with the same cache cycle together to maximize the use of the cache. Since the DOM can be accessed in the JavaScript when the browser processes the page and encounter JavaScript, it will block the DOM processing parsing. At the same time, to avoid the competition between the CSS and the JavaScript, the construction of the CSS DOM, CSS OM will block the execution of the JavaScript script. Okay. So let's talk about funding. This project aims to solve the performance optimization problem of the online inference servers. So the first one, the research practice keep the minimum compression of the model at the center level of the accuracy, so that large model often performed well, but are difficult to deploy. The pre-training model needs to be fine-tuned before the use, and the many parameters will occupy a lot of the GPU resource. At the same time, the large model requires more storage space and running memory during the deployment stage. And second one, they're using Docker. The Docker container operation configuration has also become an aspect of the cloud deployment that need to be turned in addition to computing the resource. So they're using the Docker to ensure the environment stability across the different platform. And the last one is the WSGI. this is specify a standard interface between the web server and the Python web application or web framework to improve the portability of the web application across a range of web server. Okay, so I think we can go quickly to the future work. So there is the 3 future works. First one, I would try to apply the adapt any input image shape, also support the video input, and I also try and apply the faster Fourier transform instead of the traditional convolutional kernel. So that's it. Thank you. Hi, Mahati. I don't know if there is any time to show the demo.
I think we are right on time.
Okay, thank you.
Does you have any questions for Cedric? I do have a question.
Okay.
Do you have any recommendations for the next capstone students?
For a next capstone student?
Yes, for students like us who will be taking capstone sometime soon.
Okay, so for my based on my experience, my previous experience, I would suggest those students they haven't started the capstone, they can found anything that in the field they are interested in, and also they should start earlier. That's it. Thank you.
Thank you, Cedric. Hui, would you like to start your presentation? Hui?
Yes. Wait a minute. Let me share my screen.
Sure, take your time.
Can I see my screen?
Yes.
So, hello everyone, I am Chunhui Xu. Welcome to my capstone presentation. And my capstone topic is an image super resolution model mapping solar magnetic image from MDI to HMI. So here is my agenda. I will introduce my project following this sequence. So first is problem statement. Well, because of technological change, a lot of detectors also changed. So usually the data get by the new detectors has the higher clarity than the old detectors one. So how to map the low clarity data to the high clarity data is a kind of big issue. So my motivation is using an image super resolution model to try to solve this kind of issue. So my choice is solar active regions data set, and the detectors are MDI and HMI. And the MDI is the old detector and HMI is the new one. And here is the full name of these 2 detectors. And we can see this these 2 images. The left one is an image product based on MDI detectors, and the second one is based on the HMIs. And these 2 image product is from Berger's research teams. And we can see that the image related to MDI, it has the lower clarity than the HMIs. So now is the related works. First is Berger's research group. They developed 2 image product based on these 2 detectors. But for me, I only use the magnetic map image, so I use the data from these 2 detectors directly. And the second part is the Young's research groups and the Lee's research groups. They developed several image super resolution models and with different structure. I will describe them later. And for me, in my project, I customize a new structure to solve this problem. And the last one is the Sarah's research group. They compared several mathematical metrics. In there are structural similarity index (SSIM), peak signal to noise ratio (PSNR), root mean square error (RMSE). And for me, I use the SSIM, PSNR, and the Pearson correlation coefficient (PCC) as the evaluate matrix. And then these two images are the model structure developed by the two research groups. And first we can see the Young's research group's structures. And we can find they designed several blocks and then repeat the block multiple times. And also, especially the right pictures, they embed in the features and then repeat several blocks to renew the features and then decode the features to the image. So my model has some structure a little similar like that one. And another image is in these research groups, and they also build a kind of block and repeat it multiple times, and also they linked them with the residual links. And in addition, he also used the TE as an actual feature to add to each REST block. So I also used a similar way to add the actual more features to my models. So here is my model structure. So first, the input shape is a 256 times 256 times 1's image, and then it will go through with a collisional layers. The kernel size is 13 times 13. The active function is relu. After L2 regularization, it goes through 4 downsample blocks, 3 rest blocks. And for the rest blocks, it concat the input image to add some actual more features. And the output of the rest block will go through a FAC block and upsample blocks. And these 2 blocks will repeat 4 times. And the output will go through another FAC blocks. And the output will concatenate with the input image. Finally, after a collisional layer, we will get the output. The output shape is also 256 times 256 times 1. And here is the structure of each block. First one is the downsample block. The input data will go through 2 collisional layer. The kernel size is the 3 times 3, and active function is reloops. And after L2 regularization, it will go through a max polling layer, and the kernel size and the stress size also 2 times 2, with dropout rate at 0.2. And second one is the rest block. The input feature will go with a collision layer with the kernel size is 3 times 3. After batch normalization and the reloop, the result will concatenate with the input of the model. Well, in there, the input of the model has the different data size as the output of this reloop part. So the input data of whole model will go through with another collisional layer to switch its size as same as the reloop output. And the concatenation will go through another collisional layer, and the kernel size is 3 times 3. The output of this part will residual linked with the input of this block. And then the result will go through a batch normalization layer, and after reload function will be the output of this block. Then the third one is the FAC block. This one is same as the FAC net, which is designed by Chin's research groups. This is a kind of 2D data's self attention. So input features will go through with a DCT part. The DCT means discrete cosine transpose. And then the output will go through two different fully connected layers, and their active functions are ReLU and sigmod. Then the output will multiply with the input features of this block, then output the result. The last one is the structure of the upsample block. The input data will go through a transpose convolutional layer, and the active function is mesh. Then, after drop out layer with 0.2, we'll go through another convolutional layer, and the active function is also mesh, and the kernel size is 3 times 3. Then is the data collection. Well, because my capstone project is to mapping the data from MDI's detectors to HMI's detector. So the data set is from these two detectors. And the data size is 256 times 256. And for training, when I train a model, restrict that to 256 times 256 times 1. And the training image are 1493, and the training image are 76. So, and this the training set and the testing set are from different active regions, so they don't have any similar image. So which means it will reduce some. So use the training set to predict the model. It will reduce this kind of issue. And the data value is from minus 1,500 to 1,500. And for easy to train the model, so I use the image normalization to switch that to from -1 to 1. And I also use image rotation to improve the training data's complexity. So in that case, we'll reduce some overfitting. Then there is the data analysis. The three metrics used are SSIM, PCC, and PSNR. The SSIM and PCC are both the value from -1 to 1. So when these two value close to 1 means these two image or these two data are more closer. And the SSIM is more related to the image structure, and the PCC is more related to the data's linear relation. And the PSNR is a big number. Its usually is from 30 to 50. So it's also more bigger when this metric bigger means the data is more closer. Well, in there, I just choose the 1% of the PSNR. So in that case, the value will down to 0 to 1, and it is easy to visualization with the other two metrics. So in there, you can see this graph. The left part are the matrix between the feature data and the label data. So it's the original data's the matrix, and the right part are the matrix between the label data and the predictions data. So we can see these three matrices are improved. That means the data quality also improved.
Hui, you have about 4 minutes left.
Oh, okay.
So, trying to talk.
Thank you. And there is the visual result analysis. And the left, the first row is the features from MDI, and the second one is the label from HMI, and the third one is the prediction from the model. And we can see the prediction is closer to the label more than features. And the last row is the scatter plot with label and the prediction. The X of that is the label data, and the Y is prediction. and all the plot, all the points is close to the line y equal to x. So that means these two images are close, has strong relations. So there's the finding. So my problem statement of the capstone is how to map the low quality data to high quality data. So based on the data analysis, all the three mathematical matrix have improved, and the distribution of the scatter plot is close to the line on y equal to x. So that means, so that's where we can get the conclusion. My image super resolution model is truly improved the low quality data to the high quality one, and but there also have some limitation in my project. So first one is the training set. My training set doesn't have enough data complexity. So it's the first limitation. And the second one is I don't have the high performance GPU, and it's also limited my model structure. So the future work, the first one is I will try to find more data operations to improve the data complexity. So in that way, it will reduce some overfitting issue. And second is use a higher performance GPUs. And based on that, I can improve my model's complexity. So in that case, probably my model will get them a better result. And here is my key reference. And there are three links. The first one is the source code links, and second one is the dataset links. I have packaged my dataset and uploaded to the Google Drive. And the third link is the demo videos. Do you have any question of that?
Thank you, Hui. Anybody have any questions for Hui? Nobody. I have a question.
Yes.
So if you were to repeat your capstone project again, is there anything that you consider a mistake that you would give for us as a tip?
I think, well, for I have two kind of way to improve that. First, well, one of that is like use the high performance GPU, but I think it is hard for me to do that maybe. And the second one is try to find other try to use more data operation to improve the data complexity. So probably I will use this one to try to improve my capstone project. I think so.
Okay, thank you. Well, that's all the speakers. Thank you everybody for joining today's meeting. If anybody have anything to say, please say.
Yeah, I just say thank you for the every presenter for today, and then yeah, thank you for your work.
Thank you.
Thank you, Arun.
Thank you, everyone. Thank you. Thank you all.
Thank you.
Bye, everybody.